Today, I want to talk about what the power rule is. Well, the power rule is a tool that we can use when calculating derivatives in calculus that look like this. Ax to the n. Okay? Now, using the power rule, what can we say that the derivative of this is? Right? We can say that the derivative of this equals a times n times x to the n minus 1, which also equals a n x minus 1. Okay, so let's look at some examples, right? Because the best way to learn something is to solve some problems with it. So let's just say we have 3x to the 5th, right? So what is the derivative of this? Well, the derivative of this, we take down the 5, right? And we multiply it by the 3, and then we multiply it by the x value, and we multiply it times the 5 minus 1. So this thing equals 15x to the 5 minus 1, which is 4. So the derivative of this is that. Okay, let's do another one. Let's do 5x to the negative 6. Okay, this equals, well, we take down the negative 6, we get negative 6 times 5 times x to the negative 6 minus 1. Well, negative 6 times 5 is negative 30, okay, times x, negative 6 minus 1 is negative 7. So here's our derivative for that. All right, let's look at something else. Let's look at 3x plus 1 to the 7th. Now, can we use the power rule for something that looks like this? Now, you might be tempted to do that. You might be tempted to take down the 7, right, and say that this equals 7 times, right, the derivative of this is 7 times 3x plus 1 to the 6th, but you'd be incorrect, okay? For something like this, you're going to have to use the chain rule. We'll get to what the chain rule is in future videos, but if you see something like that, you can't use the power rule for that one. Let's do one more example. Let's do negative 7, the derivative of negative 7x to the negative 7, okay? So the derivative of this, we take down the negative 7, so negative 7 times negative 7, right, equals, or sorry, not equals, times x to the negative 7 minus 1. Well, this equals negative 7 times negative 7 is 49. X, negative 7 minus 1 is negative 8. Okay? So if we take this, right, let's erase this real quick. What I'm going to do is I want to give you guys a few extra problems, right? So let's just remember, let me rewrite this. The derivative of ax to the n equals n a x to the n minus 1. I want to give you guys some problems and for you to solve. 3d over x, 3x to the negative 2 equals what? D over dx of negative 6 x to the 5th equals what? And d of dx 4x to the 2nd. Okay, so I encourage you to take a look at those, right? But before you leave, right, what I want to do is cover one more thing. If we just have the derivative, right, of an x, right, what can we do? Well, you can think about it like the power rule, right? Or you can say this is, well, this is x to the 1, so 1 times, in the front of this we have a 1, 1 times 1, right, times x 1 minus 1, right? So this is 1 times x to the 0, which is just equals 1, right? You could think about it like that, but what I want to encourage you to do is think about when you just have like an x like this, just think about it like every single time your x value increases by 1, right, your y value increases by 1. Your x value increases 1, your y value increases by 1. Think about it like that. That's a much more intuitive way to think about it, right? But you can, in fact, do that with the power rule. So I encourage you to solve these 3 problems on your own. Thank you for watching my video. Let me know if you found it helpful, if I said anything wrong, if you have anything additional to add. Have a great day.